Hey, good morning. Hey, we're going to go ahead and get 6.1 done today. This week, I would like to have 6.1 and 6.2 done. We will have the rest of the week that I'm going to put these on the videos on so that you can go ahead and get done. I will be gone on Friday, but we'll be around on Thursday to answer any questions. So let's just get started. You should have from your notes the chapter notes with the 6.1. And in this case, and that should be on your lesson plans. So today we're going to be talking about that normal distribution or probability distributions is the chapter. And today we're gonna look at a couple of different ways to calculate probabilities. The first one we're going to look at is a standard normal distribution. And I know that I showed you the norm distribution with my little gizmo that I had before. And in this case, our standard norm distribution is going to look like that bell-shaped curve again, but now our mean is going to be 0. And again, all of the probabilities that are under here will equal 1. And also might have a standard deviation of 1. So a couple of things you might want to highlight. We're going to have a mean of 0 and a standard deviation of 1. It'll always look like that bell-shaped curve that we have, and again, with the mean right down in the middle. Okay. The first one is going to be a normal or uniform distribution. In other words, what happens is that these are just going to be like a rectangle instead of that bell-shaped curve that we had. And you'll use those when you have your values are evenly spread over the range of possibilities. So let me just jump in and start with the first one. So this is going to be our uniform distribution. And so during the times of the time periods of the JFK airport in New York, the passengers arrive at the security checkpoint have a waiting times that are uniformly distributed. So if it's a uniform distribution, you're going to look for this rectangle between 0 and 5 minutes. And so what I have an area of my rectangle will always equal 1. And in this case, I have a length now of 5 units. And then I have a height then. And remember, our area of our always will equal 1. And so if I have my formulas, area is equal to length times width, I'm going to also think about in terms of that is the height times the width, which would be the same thing. And then I know that since I have from 0 to 5, my width is going to be 5. And then I'm going to look for my height. Let me just change that to h. And so by changing that, my height then is going to be 1/5 or 0.2. So each of these rectangles are what you can use to calculate different probabilities of different waiting times. So the next thing they ask us to do is find out what is the probability of a wait time being at least 2 minutes. So if it's at least 2 minutes, that means X is going to have to be greater than or equal to 2. And so I'm going to shade in those areas. So starting at 2, I'm just going to shade in this left-hand side because that would be then 2 or greater. And then I know that my height is still going to be 0.2. And then I have then the length of the rectangle that occurs between 2 and 5 would be then 3. And so I have then an area that it's going to be 0.6. That indicates that my probability of when X is greater than or equal to would then be 0.6. The second example I have is if a bank waiting times are uniformly distributed between 0 and 8 minutes, assume that the customer is randomly selected with the following given wait times. So in other words, we're going to look at greater than 5. Now again, I'm going to go ahead and find my area of my rectangle. I know that this area is going to equal then 1. And so on this case, if my length is going to be then 8, then my height has to be then 1 equals then 8 times my height. And then I'm going to divide my height, and then it's going to be 1/8. Okay, so I found that, and that's also going to be then the decimal equivalent of 0.125. So when I have that scenario, if I were to look for, say, my probability of greater than 5 minutes, so greater than 5 minutes indicates that I would have my length of my rectangle, which would be 8 minus 5, or 3. Then I'm going to multiply that times my height of the 0.125. And then I'm going to get a probability then of 3.75, 0.375. If I wanted less than 3 minutes, remember, I'm still going to go from 0 to 3. So I take 3 minus 0 and get 3. And I'm still going to get that same 0.375 as my probability. So whether it's 5 minutes or less than 3, it's the same probability. I can also find ranges between the two. Now remember, if I have a range, if I said between 2.5 minutes and 6.5 minutes, then I have like a 1.5 on this side, and then I'll have 2.5 on this side, and I can subtract that from 8, or I could even just take my 6.5 minus my 2.5, and that's going to give me a length of 4 for my area. Now I need you to go ahead and make sure on your notes, cross that 4.5 out. There's a typo, and change it to 6.5. And then again, I'm going to have then 6.5 minus 2.5, which is 4. And I'm going to multiply it times the 1.25. And so my area then is going to be then 0.5. Now on a standard norm distribution curve, there's two different ways that we can kind of calculate using it. We're going to we're going to do StatCrunch, and we're also going to use our z-score distribution table. And I'm going to show you both. The table that you have there's also some in your modules that you can print off. I've also added it to your lesson plans. And so I have a Z table that looks a little bit like this that you guys can print out or just use. It's under your label in your lesson plans. Honestly, the technology is pretty awesome. So I'm going to show you how to use the technology as well as the chart. Okay. Keep in mind when you're given the z-scored distribution table like this, okay, a couple of things you need to know is that there's 2 pages, with the left page being the negative z-scores and the right page being the positive z-scores. All of your z-scores then are represented with your equate to your probabilities. So in other words, if you were a z-score that would be just 0.1, what you're doing is it'll be just, remember, the 0 is going to be at the middle, and so you're just, let me put this real quick, this would be a lot like if I had just 0.1. That means I'm just right over here to the tiny little bit over there, and that's where you're saying that a z is going to be 0. 0.1 is going to be then 0.53. So, and then it's going to continue as the numbers get bigger, then you're going to have more of the area, which is going to represent your probability. I want to make sure that each value of the body of the table is a cumulative area from the left. Okay, so again, if I'm looking for maybe this area here, I'm going to have to think about what I can do to subtract that out, because your Z table is going to be giving you this amount over here that's not shaded. The Z-score is a distance along the horizontal scale of the standard normal distribution, and it corresponds to the number of the standard deviations above or below the mean. And then remember, the area is the region under the curve that refers to the body of the table. So let me just jump in and do a couple of problems. Page 6 talks a little bit about what you can find and also some of the technology that you can use because your calculators will do this. I'm going to encourage you to use StatCrunch, and that's what I'm going to go ahead and show. Using StatCrunch, here is the one I'm going to star this, and I'm going to show you again where to get this, but you will open StatCrunch. You're going to click on the stat and then calculators and look for norm. So those are the steps that you'll get to have your norm distribution table pull up. So the probability. So let's look at this. It says the bone density table is helpful in identifying the presence or likelihood of osteoporosis, which is a disease of the bones actually becoming more brittle as we get older. The result of the bone distribution density table is commonly measured as a Z-score. The population of a Z-score is normally distributed, and the mean is 0 and the standard deviation is 1. So a randomly selected adult undergoes a bone density test. Find the probability that the person has a bone density score less than 1.27. So when I look at the problem, I'm going to go to my Z-score. In order for me to read the Z-score, I'm going to come down. This is going to be my my scores, and it's going to be like, if I, for instance, I'm going to have the first two digits, 1, and then the tens column. So I'm looking for 1.2, but I need to have 1.27. So that means on the 1.2, on the column in the first, I'm going to move over until I see 1.7. And so I'm going to come up 0.007, and this is the number then that would be corresponding with 1.27. So it's 0.8980. And so what that means is that that is going to be that the probability that you have a z-score of 1.27 would be then the 8.8980. The second page just kind of talks to you, just what I went through is the how we came down and looked for the columns. And then the interpretation, okay, the probability then is going to, of the 1.27 is going to have a probability of 0.8980, which would mean that 89.8% of the people have a bone density levels that are going to be below this amount. That's the interpretation. Now, using the bone density test, find the probability the person is going, the results are above 1 or a negative 1. So in other words, here's my negative 1. It'll be to the left of my mean. And they want to have all of this amount. And so we're going to look first of all for the number for Z for a negative 1. So I'm going to go back to my table and I'm looking for negative 1. And I noticed that my negative 1 is also corresponds with a probability of the 1.58. So when I look here, a negative 1 is the 1 point, because it'll go to the 0, 1.87. So remember, that's representing that amount to the left. So in order for me to get the amount that I really want is going to be greater than that, I would want to subtract it from 1. So 1 minus 1.587 then is going to give me the amount of the 0.8413. Okay, StatsCrunch. If I go to StatsCrunch, share my desktop. Okay, I'm going to show you again the to get that calculator open, you go to, remember the process is right here on your notes. So stats, calculator, and then normal. So I'm going to click on stats. I'm going to calculator, and I'm going to also go to normal, which is down here. And it's going to open up my z-score now, or my norm distribution table. Now remember the problem that we had on that one said that we were looking for a z-score of -1. So if I go ahead and put in a z-score and I go -1, okay, and I compute, then I'm going to get that one side, which is the left-hand side. But by changing in my greater than or less than, I can have it switch, and that will also give me the same amount. So again, it's nice because you don't have to use your table, and it's also right there, and it's really handy to use. Okay, so our next problem, okay, back to the bone density. Let's see, we're gonna also do, we found that the area of -1 is going to be the 1.57. This time they said, what is the bone density readings between -1 and 2.5 and indicate the subject has osteoporosis, which means there has been some bone loss. The probability of randomly selecting a subject that readings between the -1 and -1.25. So again, drawing that out, your z-score would be a -1 would be the amount that we found earlier, which would be the 1.57. If I go ahead and look for the z-score of -2.5, I'm going to come here, I'm going to go -2. Negative 2.5 indicates then I would have then coming over would be the 0.0062, which is right here. And then to find this, that means that this little tiny tail is going to be 0.0062. But I want to find all of those between those amounts. And so to find out that probability, then I would want to subtract off then the amount for the 0.0062. So in order to find the amount between -1 and 2.5, then I would subtract, and I think that's there somewhere. But I would want to go ahead and take out my probabilities, and I would have then the 1.1587 minus then 0.0062, and that's going to give me just the probabilities between those amounts.